Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yakoob. So now people in this online class, we are now starting with partial fractions. Yes, this is lecture 1 of partial fractions. And last time we completed binomial expansion. This is P3. Now, what is the story behind partial fraction? In basic maths, a question is asked, write as a single fraction. And that thing is something like 1 over x plus 2 plus 3 over x plus 4. Write it as a single fraction. So what do we do? What we do is that we take LCM and underneath we write x plus 2, x plus 4. This 1 is multiplied with x plus 4. So 1 is multiplied with x plus 4. This 3 is multiplied with x plus 2. This 3 is multiplied with x plus 2. And there is a positive sign already in the middle. You keep the denominator as it is, which is x plus 2, x plus 4. Do not expand. And 1 is multiplied with x plus 4, which is x plus 4. 3 is multiplied with x plus 2, which is 3x plus 6. Simplify a bit. That is 4x plus 10. And this thing is divided by x plus 2, x plus 4. That is writing the answer as a single fraction. So now this method over here, this strip over here, versus the strip that I'm writing over here. What is the difference if I go this way? This is O-level maths. This is IGCSE maths. This is basic maths. But if I plan on going the other way, now this is pure maths P3, and this is known as partial fractions. So breaking into its partial fractions. This is the concept that we are learning right now. Now let's start with the first case of partial fraction. So case number 1 of partial fraction. Let's focus on denominator with linear factors. If I focus on denominator with linear factors, let me just take the same thing, 4x plus 10, x plus 2, x plus 4. 4x plus 10, x plus 2, x plus 4. If I'm not mistaken, yes. And they would ask us to break it into its partial fractions. So what we will do is that we will write two fractions. That means this should be identical to. This is the symbol for identical. The first denominator has this bracket x plus 2. The second has this bracket x plus 4. By the way, we term this and this as the linear factors because the power of x is 1 and that is the linear factors. So whenever a question is there, we will first factorize the denominator if it's not already factorized. So that is rule number 1. First factorize the denominator. It is denominator with linear factors. So that's how you will write it. You will write a constant over the first factor. You will write another constant over the second factor. And there is a positive sign in the middle. So that is how you would open it up. So that is the first thing. The strategy. So the strategy is we will focus on the numerator later on. Denominator decides the case. And according to the case, write out the fractions. And then the next step is solve for unknown constants. And then the next step is write the final answer as PF, partial fractions. So that is the simple strategy for this. So now let me just grab this thing. Hold for a second. And let me copy this thing. Let me take it to the next page. And now I want to solve it out. So let me remove this thing, this thing, this thing over here. And let's start the working. So now the working is this A, even before that, the LCM, that is x plus 2, x plus 4. This A gets multiplied with x plus 4. This B gets multiplied with x plus 2. Now both fractions are identical. If both fractions are identical, the denominator already equals the denominator. Therefore, this numerator should equal this numerator. And now let's focus on the numerator. So therefore, 4x plus 10, this is identical to a constant times the first factor, another constant times the other factor. There are different ways of solving it. Let's use the concept of identity. True for all values of x. Whatever value you put on the left-hand side, whatever value you put on the right-hand side, it should be identical. Like identity a plus b whole square, that's an identity. That is a square plus 2ab plus b square. Similarly, a minus b whole square, that is also an identity. So this minus will give me this minus. And then we have the trigonometric identity. That is sine square theta plus cos square theta equals to 1 or identicals to 1. So now similarly, if I think a little bit wisely, and if I say, let me choose x is equals to negative 2. So negative 2 plus 2 is 0. 0 will wipe away b, and I'll be able to find a. So yes, I can choose any value, but my objective, my strategy is to choose nice values which will eliminate one constant at a time, if that is possible, which is possible in this case. So let me choose, if I want to solve for a, let me choose x is equals to negative 2. Let x is equals to negative 2. 4x plus 10. 4 into negative 2 plus 10 is identical to, what do we have? A times negative 2 plus 4. A times negative 2 plus 4 and b times negative 2 plus 2. This thing is gone. This is 0. B disappears. So negative 8 plus 10 is 2. This is 2a. Therefore, a comes out to be 2. That's the a comes out to be 1. That is the answer. Now let me write this thing again. 4x plus 10 is a times x plus 4, b times x plus 2. Let me just pick this thing up. Again, copy. On the next page. And let me remove this thing. Okay. Now we have the value of a, that is 1. Now choose any other value. Which value will make a disappear? So let x is equals to negative 4. So 4 times negative 4 plus 10. This is identical to or equal to, for this value, it's equal. That is 1 times negative 4 plus 4. b times negative 4 plus 2, negative 16 plus 10, negative 6. This is 0. This is negative 2b. Therefore, b comes out to be 3. And once I plug in the value, let it remain as an equal sign. So the value of b comes out to be 3. So we got a as 1, b as 3. A is the numerator of x plus 2, b is the numerator of x plus 4. So a is the numerator of x plus 2. So let me write it. A is the numerator of x plus 2. B is the numerator of x plus 4. There was a plus sign in the middle. This is the full and final answer. This is how we break into partial fractions. So let's pause for a moment. This is worked example 1. Let me share the images so that you people can copy it out. So now people, let's continue the journey. So this was a basic example. Let's now focus on past paper question. How would you determine whether this is a question of a particular case? Look at the whole fraction. The first checklist is you will look at the numerator also. And if the degree, the highest power of numerator is lesser than degree, the highest power of denominator, it's a proper algebraic fraction. And then you would look at the denominator and then decide the case. So currently, all the questions that I'll be giving you, they will be fulfilling the first thing. The first thing is the numerator. The highest power of numerator is lesser than highest power of denominator. It's a proper algebraic fraction, so you can start right away. If it's not, that we will study in case 4. The second thing, now focus on the denominator, decide the case. This is a linear factor, LF, always factorize the denominator. LF, that means linear factor. So if it's a linear factor, if it's 3 brackets over here, that means it is 3 fractions. So let's get started. 2 plus 11x minus 10x squared divided by 1 plus 2x, 1 minus 2x, 2 plus x. This is identical to a constant over the first factor, that is 1 plus 2x, another constant over the second factor, 1 minus 2x, and another constant, which is c over the third factor, which is 2 plus x. Positive sign in the middle, positive sign in the middle, and then we have this thing, which is for the fraction. So that's for the fraction, the first one, the second one, the third one. This is still the first case, but there are 3 fractions. That's the only new thing. Now, let's take LCM. So when we take LCM, it's a big line that I have to draw. It's identical to what? First of all, focus on the LCM. 1 plus 2x, 1 minus 2x, 2 plus x. Don't forget to put a bracket. It's always better. A, when I compare for A, it already has this, so it will multiply with these two. So this A gets multiplied with 1 minus 2x and 2 plus x. Similarly, this B gets multiplied with 1 plus 2x and 2 plus x. And last but not the least, let me just push it a little bit over here. That is over here, which is C. That is being multiplied with 1 plus 2x, 1 minus 2x. And let me just remove this thing and draw it a bit longer. So all the way like this. Now focus that this thing is the same. So now over here, this thing is the same thing as this thing. Both fractions are identical. Therefore, the numerator should equal to this numerator over here. Got the idea? So let me just change this thing, draw in a straight line, not necessary. So let me, this numerator equals to this. Now, let me rewrite this again. And now we have to do a lot of working. So 2 plus 11x minus 10x square is identical to a times 1 minus 2x, 2 plus x, b times 1 plus 2x, 2 plus x, and I need some more space. So hold for a second. Let me push this over here. Let me push this over here. And then we have c, that is multiplying with 1 plus 2x, 1 minus 2x. Now let me copy this whole statement and paste it thrice on the next page, so that we have to solve for all these values. So now let me paste it at the top. And then let me paste it over here. And then over here. So now one by one, we will solve. Doesn't make a difference the order in which we can solve. If I choose x is equals to -2, these two brackets will become 0. So technically, the background knowledge is 2 plus x equals to 0, x is -2. So therefore, I'll write let x is equals to -2. So therefore, this is 2 plus 11 into -2 minus 10 into -2 square. Can someone please grab a calculator and help me out? And this is a becomes 0, b becomes 0, c is 1 plus 2 times -2, and this is 1 minus 2x. So this is 1 minus 2 into -2. Now the left-hand side that you have to give me, this is, just remove this thing, which is over here. Just have an equal sign. Once you plug in a value, then it's about an equal sign. So this is c multiplying with -4 plus 1, that is -3. And this is 4 plus 1, which is 5. And what's on the left-hand side? So let me look at my WhatsApp. Maybe someone has given me the answer. No one. -60. Thank you, Hiba. So this is -60. That is equals to -15c. Therefore, c comes out to be +4. That is the first constant that's found. Whatever you have found, let's make a habit of writing it. Whether it's useful or not, let's make a habit of writing it. Now this thing is done. Let me choose another value. If I focus on this bracket, 1 minus 2x, 1 minus 2x, that means 1 minus 2x equals to 0, x is equals to half. Again, let me choose the value, x is equals to half. So this is 2 plus 11 into half minus 10 into half square. Can someone please simplify this? That is equal to a disappears, c disappears, b is 1 plus 2 into half, 1 plus 2 into half, and this is 2 plus half. So this is b into 1 plus 1 is 2, and 2 plus half is 5/2. What's on the left? 5. Okay. So 2 cancels out. 5b is equals to 5. Therefore, b comes out to be 1. Therefore, b comes out to be 1. And c was already found to be 4. Got the idea? Now, in order to find a, there are two options. The two options are either I can choose a value in this manner. I can choose let x is equals to 1 plus 2x equals to 0, x is -half. That's one approach. Or let me choose another approach, that is Since we already know the value of b, since we already know the value of c, let me choose a simple value. Let x is equals to 0. So if x is equals to 0, I have 2. This is equal to, it's no more identical, it's equal to, this is a into 1 into 2, b is 1 into 1 into 2, c is 4 into 1 into 1. So therefore 2 is equals to 2a. This is 2, this is 4. Now these two will also cancel out. 2 and 2 cancels out. 2a is equals to negative 4. Therefore a comes out to be negative 2. So I found the value of a, which is negative 2. And yes, the answers are over here, negative 2, 1, and 4. So now the very final answer that I'll write over here. So now the final answer for part A, that is this thing, express fx in partial fraction. So a is negative 2. And then we have b as 1. And then we have c as 4. The numerator of the denominator of a is 1 plus 2x. So this is 1 plus 2x. And the denominator of 1 is 1 minus 2x. And the denominator of 4 is 2 plus x. That is the answer of partial fractions. That's how it's done and dusted. Just have a good look. This was still the first case. The checklist includes looking at the numerator. It's a proper fraction. In case 4, it will be improper. Of course, in the exam, it won't be labeled as case 1, 2, 3, 4. So that's why the checklist is there. It's a proper fraction. You can get started right away. Look at the denominator. If it's 3 linear factors, 3 fractions, take the LCM. Both fractions are identical. The denominator equals the denominator, numerator equals the numerator. And now you work it out one by one in any order, found the value of C, found the value of B, wrote it down, plug in any simple value and find the value of A. And that is how this thing is done and dusted. And let me just change the color over here. Okay, so this is you find the value of A, which is negative 2. So this is over here A. This over here is C. This over here is B. And that's how this thing is done. Now, I won't be focusing on part B at the moment. Let me first finish all the cases. Then I'll go to binomial. So now this thing is done. Let me move on to the next case. Now the next case is this thing. That is case number 2. So we are on partial fraction case number 2. That is denominator with quadratic factor. That means a quadratic factor is something that is quadratic and not factorizable. So if it's factorizable, it won't be termed as quadratic factor. For example, if I have a case like this, and this thing, let me just, okay. So now if I have 3 plus 2x over 1 plus x and 4 plus x square versus 3 plus 2x over 1 plus x and 4 minus x square. So what is the difference between the two? The difference between the two is this plus and the negative sign. If it's a plus sign, it's not factorizable. So since it's not factorizable, we say that this is a quadratic case. And over here, this negative sign, this is factorizable. A square minus b square, that is a plus b, a minus b. So therefore, this is 4 minus x squared, that is 2 plus x, 2 minus x. So basically, this thing boils down to this thing. This thing becomes this thing, 3 plus 2x, 1 plus x, 2 plus x, 2 minus x. So this would be case 1, which is denominator with linear factors. And this will be case 2, which is denominator with quadratic factor. So that is how the differentiation, the discrimination between the two is done. I hope this is all got all clear. Now let's look at this question. So we will start with the past paper question right away. Now look at fx. This is 14 minus 3x plus 2x squared. And this is identical to, let me just make this template first. This has a denominator of 2 plus x, and this is 3 plus x squared. So over here, let me write over here 3 plus x squared. This is what makes it quadratic. And this is a quadratic factor, and it's not factorizable. We are not focusing on the numerator because we already know it's a proper fraction. So yes, it's a proper fraction. Also have a good look. Because the highest power of the numerator is 2, the highest power of the denominator is 3. So all these cases, for right now, we are dealing with proper fractions. Now, how do we write it? First of all, you will write 2 plus x in the denominator. You will write 3 plus x squared over here. You will write a positive sign over here. On top of the linear factor, we write a. On top of the quadratic factor, we write a linear expression that is the standard. So the standard is this. This is linear. This is constant. This is quadratic. This is a linear expression. That is how we write it, and we write it inside a bracket because when we take LCM, we don't want to commit any mistakes. Okay, so that's the strategy. Now, let me write over here after taking the LCM. So this is 2 plus x. This is 3 plus x squared. A is multiplying with 3 plus x squared, bx plus c. If I forget the bracket, what happens? This is multiplying with 2 plus x. So if I forget, it seems that the c is only multiplying with 2 plus x, whereas in reality, the whole thing is multiplying. So brackets are for free. Use them excessively. Now, again, the two fractions are identical. The denominators are the same. Therefore, the numerators should also be equal. Let me write it out. So 14 minus 3x plus 2x squared. 14 minus 3x plus 2x squared is identical to a times 3 plus x squared bx plus c in brackets multiplying with 2 plus x. All good, all clear? So now let me just copy this thing and let me paste it on the next page. And again, the same way, we have to paste it thrice so that I'm giving you a template, how things will work out for you. Okay. So now we would go in a particular order. We cannot go randomly. Now 2 plus x is here. If I make this thing 0, these two constants will disappear. So therefore, I'll choose let x is equals to negative 2. 14 minus 3 into negative 2 plus 2 into negative 2 square. That is identical to, after plugging in, it becomes equal to 3 plus negative 2 square. Bx plus c becomes 0. This is 14. This is 6. This is 4 into 2 is 8 is equal to 2 square is 4. 4 plus 3 is 7. That is 7a. So this 28 is 7a. Therefore, a comes out to be 4. Make a habit of writing. A comes out to be 4. Now, the next thing. Now you have to choose let x is equals to 0 because you cannot eliminate two constants at one time. You just have to focus on this. So therefore, 14, this is 4, 3 plus 0 square. Bx becomes 0, c remains as it is, 2 plus 0, 14, 12, 2c. 14 minus 12 is 2c. Therefore, c comes out to be 1. So c comes out to be 1. P was already found as 4. All good, all clear? Have a good look. First, you found by making x is equals to negative 2, you eliminated B and C, you found A. Write down the value of A, choose X is equals to 0. You found C. So first A, then C. Now plug in both the values and choose any other value. Let X is equals to 1, a simple value. 14 minus 3 into 1 plus 2 into 1 square. That is 4 times 3 plus 1 square. This is B into 1 plus 1 into 2 plus 1. This is 14 minus 3 plus 2. So 14 minus 3 plus 2, this is 4 into 4. This is B plus 1 into 3. I'm going very, very gradually on the working. 14 plus 2 is 16. 16 minus 3 is 13. 4 into 4 is 16. And hold for a second. Let me remove the extra equal. So therefore, this is B plus 1 into 3. I can write this thing as 3B plus 3. So therefore, 16 plus 3 is 19. 19 and 13, the difference is negative 6, is 3B. Therefore, B comes out to be negative 2. So now the very final answer is this thing. Let me write the fractions. Let me put a positive sign over here. The first one has a denominator of 2 plus x. The second one has a denominator of 3 plus x squared. B is negative 2 and C is 1. So this is negative 2x plus 1. Write it in a bracket. You can also write this thing as 1 minus 2x. And the value of A is 4. That's how this is written. So this thing, that's the value of A, which is 4. Okay? So that's the value of A, which is 4. And then you found the value of C, which is 1. And then you found the value of B, which is negative 2. So that is how this thing is written. Okay. So now just a caution, that is Bx plus C. Sometimes you will find a value of B, you will find a value of C. Sometimes the value of B will be there and C can be 0. Sometimes the value of B could be 0, you find a value of C. Of course, it's not possible. You find both the values as 0. That is simply not possible at all. I hope this is all got all clear. So just acknowledge it individually. The group is not yet formed, but it's all good, all clear. So we did, mashallah, one question on the basic, one question of past paper, another question of past paper, and then, yes, we will be working on this thing, which is the partial, or which is the binomial thing. Okay. So let me just get started with one of the questions. That is this one. Can we do the binomial thing? Yes, we can. So let me just copy this thing. And let's go on the next page. And now, what does the question say? The question says, let me copy this thing. And now the question says, what is this? Hence obtain the binomial expansion. Hence obtain the expansion. That means the binomial expansion of fx. This whole thing is fx, for which you have already broken it down into partial fractions. In ascending powers of x up to and including the term in x squared, that is 5 marks. By the way, the first part was 5 mark. The second is also 5 mark. Now we have already studied binomial. Let's have a look. This is 4, 2 plus x raised to power of negative. This is 1 minus 2x raised to power of negative 1, 3 plus x squared. And my bad, hold for a second. There is no power over here. So this is 1 minus 2x. And this is 3 plus x squared raised to power of negative 1. Okay. So now let's do each expansion separately. So this is 4. This is 2 plus x squared raised to power of negative 1. That is 4. 2 common. 1 plus x squared over 2 raised to power of negative 1. And this negative 1 is applicable not only on the constant, not only on the bracket, also on the constant. So therefore, this is 4. This is 2 raised to power of negative 1 is half. This is 1 plus x square over 2 raised to power of negative 1. We studied it last time. So this is 2, this is 1, this is negative 1 x square over 2 power 1 divided by 1 factorial. And I don't need the other term. Why? Because negative 1, negative 1, negative 1 is negative 2 x square over 2 raised to power of 2 divided by 2 factorial. This is not asked for. Or maybe, no, I can use it. I can use it because I'll be multiplying with 1 minus 2x. So this is good. Let me add a page. This is 2. This is 1 minus x square over 2. This negative negative cancels out. This thing cancels with this. These two things cancels with this. This is positive. This is negative. And this is 1 minus x squared over 2. Let me go back over here. And this is x squared over 4. X power 4 over 4. Now you think that I won't be needing it. 2 minus x squared plus x4 over 2. Because this is x4, that's why it's not needed. Up till x square is good. This is not needed. That's the first thing. Let me focus on 1 minus 2x, 3 plus x square raised to power of negative 1. 1 minus 2x, 3 plus x square raised to power of negative 1. And I made a small mistake. Let me correct myself. This is power 1. 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 So therefore, there was this mistake. Okay. So this is power 1. This is this. This is this. This is x. This is x squared over 4. This is x. This is x squared over 4. I need all the three terms. So in a hurry, I made a mistake. Now over here, just focus on 3 plus x squared raised to power of negative 1, 1 minus 2x later. So 3 common, 1 plus x squared over 3 raised to power of negative 1. This is 3 raised to power of negative 1, 1 plus negative 1 x squared over 3 raised to power of 1 divided by 1 factorial. And the other term, negative 1, negative 2, x square over 3 raised to power of 2 division by 2 factorial. This is not needed because this will be x power 4. So now this is 1/3. This is 1 minus x square over 3. This is 1/3 minus x square over 9. This thing is done. Now let's gather the forces. 2 minus x plus x square over 2. Actually, you have to multiply it out. 1/3 minus x square over 9. Don't forget to multiply with this 1 minus 2x. So this is 1 minus 2x. So now 1 into 1/3 is 1/3. This is minus x square over 9 minus 2x into 1/3 minus 2/3 x. And this is positive 2x cube over 9. Again, discard. Why? Because I don't need cubic term. So far, so good. This is 1/3 minus 2/3 x plus minus x squared over 9. Now these three terms and these three terms, 2 minus x plus x squared over 2. So now this is 2 minus x plus x squared over 2. This is 1/3 minus 2/3 x. And this is minus x squared over 9. Add it up. And after adding it up, this is what you will be getting. 7/3 minus 5/3 x plus 7 over 18 x squared. So this is where I'll stop lecture number 1 of partial fractions. See you in the next class.